All right. So thank you all for attending. Um, this is awesome that we're all able to come together and virtually and see each other through webcams and stuff, and we're able to turn those on. So this session is common SQL Server mistakes and how to avoid them. It kind of came to be. I started off. This was you inherited a database. Actually, it was you inherited a neglected database. Now what? Kind of dropped the neglected. And then over the years, I realized that I'm still talking about the same things. It's as I work with different customers, as I meet other data professionals, and we're just talking at events, we're all still finding the same thing. So I have had a series of blog posts, and then this was actually my first ever session that I presented at a SQL Saturday in Tampa, Florida. I think it was SQL Saturday 62 or 64, I forget the exact number, but it's an early number there. And it's all of this is still true. It's morphed a little bit now that we have Azure SQL Database and managed instance, and we have virtual machines, and we have different templates for Azure VMs, but so much of it is still true, so we still talk about it. Let me advance the slide here. I had mentioned early before we started the session, individuals were asking about additional resources and things like that. And I mentioned Pluralsight. Now, Pluralsight is a low-cost subscription. I think it's like $15 a month, so it's very affordable, even if you were paying out of pocket. Many organizations have a corporate subscription, so make sure to ask. But if you email Paul at SQLskills.com, good buddy of mine, he'll send you a Pluralsight code good for 30 days of all the SQL Skills content, which is almost 200 hours. So 30 days for all of those courses. Take a lot of PTO to try to get through all of those. But look through the library of anything tagged with SQL Skills that's in that library, and watch it for free. I mean, it's awesome. I do have a 2-hour course on Azure SQL Database. It's mostly all still accurate. There's been a few changes. There's a few more tiers I need to redo that course. And then I have a very intro course on understanding database fundamentals. All right. How to contact me, Tim at timradney.com, my website, timradney.com. I will be posting this slide deck. I'll also make it available to your chapter leaders so that they can get that on the meetup, so you can download as well. You can also take notes, but the slides will be made available. If you need them immediately, just email me, Tim at timradney.com, and I'll send you the PDF after the course. All right, we're going to cover a lot of things. I start with backups and consistency checks. That's one of the areas that I see kind of missed a lot. And to me, that's one of the most important aspects. If I can't recover the database, we have a problem. And then we'll talk about a lot of instance level things such as max stop, cost threshold for parallelism, some maintenance like log cleanups, which ones you can take a look at, statistics, how to configure TempDB, index maintenance, your memory settings, SQL Server alerts, that's free monitoring, and lastly, power savings. You'll notice at the bottom where it has the SQL DB, SQL DB MI, SQL IaaS, and SQL on-premise or on-prem. I have this on here because as the platform as a service and infrastructure as a service started becoming more prevalent, customers migrating to cloud, just like we had Greg saying, hey, we're looking for an Azure top level DBA for our company. We're seeing that. So which of these apply to SQL database, to SQL SQL managed instance, to SQL on an Azure VM, or you're installing it on your on-premises, either bare metal or a VM. So we have these little color blocks, and in the top right, you'll see where they apply. So why does backups not apply to your SQL database or your managed instance? Because they're handled for you. So that's part of the platform as a service. Your backups are all automated. You have really no control over them. Your managed instance, you could do copy only level backups to restore to another MI, but this really applies to you're responsible for the instance in an infrastructure as a service or on premises. So what are we looking for? Do you have recent backups? That's it. I mean, are you taking backups that meet the service level agreement for your organization? So they need to be adequate. You can have a full backup, but if you need point in time, the full is not enough. So what is your recovery point objective? Meaning, how quickly do you need to, or what time do you need to restore to, meaning how much data can you afford to lose, versus your RTO, which is recovery time objective. How long can you be down? How long can you take to restore the environment to where end users can connect back in? Those two things will determine how you plan your recovery strategy that will dictate what your backup strategy is. So you don't plan a backup strategy. We're planning a restore strategy, and then we have to figure out what level of backups we need to meet that. So such as 15 minutes of data loss, no more than 4 hours of downtime. Okay, what model do we need? What backup routine will help us achieve that? What HA solution may be needed as well? So definitely the right recovery model. So full or simple. And then do you validate your backups? How do you know that they're good? How often do you restore those? Many of us are in a regulated environment. Finance, insurance, healthcare, some government bureaucracy telling us, coming in to make sure we're doing what we're supposed to do and that we can recover and that we're protecting the data and all of those things. And a big part of that is that you can recover. So if we're in those types of environments, I came from banking, heavily regulated. Examiners would come in, they would want to see us go through and restore databases to prove that we are doing what we say we can do. When you have a restore validation process in place where you've automated or you're manually going through and restoring databases on a regular interval, you can report on all of that because it's all stored in MSDB. Your backups, your restores, how long they took, the file sizes, all of that information. So if you can produce that, you have a log book. When the examiners come in, you hand it to them. They tend to look at that and it's like, well, you're a very mature shop or team. We're going to leave you alone and go harass another group. Actual words spoken to me by an FDIC examiner, I'll go harass another team. They acknowledged what they were doing. So when I get a new customer, if I'm not doing a full assessment like a health check, I'll send them a script. You can get it at timradney.com/backups. It's a script you run. It pulls back the database name, the recovery model, when was the last full taken, and then the last 2 transaction logs. With that, I can extrapolate a lot of information. Are you in full recovery with no transaction logs? It means you probably have a runaway transaction log that's much larger than it needs to be because it's been storing all this data. It's not being backed up, so it hasn't issued a checkpoint, so it just continues to grow. The 2 transaction logs, or 2 transaction log backups, I can see what the backup time is. So what is your interval? Are you doing log backups every 5 minutes, 15 minutes, 2 hours? What is it? I've seen some customers or some people out there, they do a nightly full and a nightly log backup. So they do a full and then immediately do a log backup. So they assume, hey, we're doing transaction log backups. No, you're doing one immediately after the full backup. You have no point in time recovery except for when the full and the T-log backup was taken. All right. So yeah, you can take a look at that script. Let's see, is there anything else I want to cover here before I move along? All right, so when I mentioned having that restore, I pause because I have a couple of versions of this. My extended version, I've broken out and gone into more detail, but there was a case where a buddy of mine was contacted from another financial institution where they were doing quarterly full backups, log backups every 5 minutes. And they had a catastrophic issue with the data file corruption. The only way to get things back were to restore from backup. I mean, system was down, data files messed up, the transaction log file still there, so they could back up the tail end of the log doing a hack attach. So they were able to do that and get the final log back up, but essentially the system was down. So they had to go off-site to get the LTO tape libraries to bring those in and do the restore. And this was a multi-terabyte system. So fast forward, at the end of day 4, they got the database back up with 0 data loss, but they were down for 4 days. This was a bank. How long can banks be down? 3 days, typically a Saturday, Sunday, and a federal Monday holiday. So the FDIC stepped in. It was a really, really bad situation for this customer, or this bank, but yet they were able to restore with zero data loss, but they couldn't meet the recovery time objective. Recovery point, they were on, zero data loss. So that's why we need these restore validations. You need to know how long these backups take. And depending on the size of the environment, because many databases, they expand over time, they continue to grow, they get larger. Just because you were able to recover it in 4 hours before, now it's multi-terabyte, maybe you can't. When does your time begin, that recovery time objective? When does that start? At the moment of the issue. Well, what if the issue is, the storage array went away? Well, now the SAN admin has to get the infrastructure back. Somebody's got to, do they attach it to an existing VM, or did you lose it too and they have to restore the VM? So it could be several hours of time before you ever get to start restoring SQL Server, right? So if it takes you 3.5 hours to restore just the data, you have a 4-hour recovery time objective, you probably need a HA solution sitting somewhere. So all of these things kind of play into each other to know that you can recover the environment in the time that's needed, where people are willing to pay for that solution. Because high availability, disaster recovery, it comes at an expense. You're duplicating compute, you're duplicating storage. Sometimes people want to pay for it, sometimes they don't. When they don't, just make sure that people are aware and that you have that email filed away somewhere, right? And then when management changes, bring it up again, because ultimately you're responsible. If the blame's going to get land somewhere, at least you can say, hey, I've brought this up multiple times that we have this potential situation with this business critical environment, and I have these conversations almost monthly with different people. So biggest thing, just make sure you can recover. That's my number one. All right, next I'll step into corruption. So most people know that you need to do some level of backups. I rarely find someone that's doing no backups. I say rarely, but once a month is, we get a lot of emails from people where they had an issue and they realized they didn't have proper backups, meaning they weren't taking them or it was 3 months old. So that happens. But consistency checks is where you're looking for corruption. Now, this can be physical corruption, but I would say 999 out of 1,000 cases that I've worked over the past 10 years has been logical corruption. Rarely do I find where a sector on a disk went bad that caused a problem. It's almost always some I/O subsystem problem where an extent was written to disk, meaning all the ones and zeros. Something happened and now it's all zeros. Well, it's logical corruption, meaning SQL Server, the database is still fine, but when it goes to read that page, it's empty. Kind of like I go to look in my wallet and there's no money because one of my kids needed to go somewhere and they took money. The wallet still works, but the ones and zeros are gone. So similar. So how do we check for that? Well, we need to run dbcc check db. There's other commands like you can check just the allocation tables, you can check just the catalog, you can check individual file groups. But the root thing is we need to run checkdb on a regular schedule. Typically, this is once a week. And if and when dbcc checkdb fails, you need to take immediate action. The reason being is sometimes the fix is a restore. How long are you keeping backups? Right? So if checkdb runs once a week and you're only keeping 14 days worth of backups, if depending when the corruption occurred, if it was right after the full backup ran, so full backup runs, or that you run checkdb, you have a full, the scan runs, and then a day or two later you have corruption, you may have 5 or 6 days of corruption sitting in that database before the next checkdb scan runs. So now you're already 5 days into your backup retention before action could be taken. What if you're on holiday that week? Then you come back, you have all these emails, you see this one failed checkdb, but you're responding to other urgent things. Maybe a couple of days pass, and then you go to check. Well, you just lost the full backup that occurred before the corruption occurred, and now you can't restore prior to the corruption. That could be bad. So typically I like to see 30 days of backup retention, CheckDB being run at least once a week, because you see 99.98% of the corruption is from when some IO subsystem problem, meaning it was something at the subsystem layer where an extent got zeroed out that was not part of the transaction. The transaction, the full backup transaction logs, it contains it all, all of it. You can still restore with zero data loss. You back up the tail end of the log, you restore the full, your diff, all your transaction logs since, including that tail end, you're back whole. It was something happened outside of SQL Server, outside of the database, that zeroed out part of the file. The file's still good, it's just your data is missing. So you get it back from restoring. If it's a problem with a non-clustered index, then you can just drop and recreate the index. So I kind of call that soft corruption. It's a non-clustered index. So if CheckDB fails, it says the minimum repair is to run dbcc CheckDB with repair or repair rebuild, then you're good. It's basically just going to go through, drop and recreate the index, and you're okay. But if it's the heap or the clustered index, it's the physical data. You can only get that back from a restore. So if it says the minimum is run repair rebuild with allowed data loss, that's exactly what it's going to do. You're going to lose data. So good data, bad data. I mean, it could be customer data. It could be archive, audit, something that's not really relevant, but you don't know. So the only way to truly fix it is to restore from backup. So we need to take that immediate action. If Paul and his company at SQL Skills, they get emails like this at least once a week, where somebody's run into corruption, all of these ransomware where they encrypt and everything, and people pay the money, and they try to decrypt, and the database still isn't whole, and hey, we don't have proper backups. I mean, it's so common. So we need to be running CheckDB. We need to know when this stuff happens. Now, in SQL database and managed instance, they're doing a lot of things on the back end. You're from a physical corruption, almost impossible. In the way that they have 3 copies of the data and they're doing so much error handling and everything, you're in pretty good shape. But what if an extent got zeroed out? They do run some levels of checks and things, but you're talking to friends, there, it's like they have a blog post saying, hey, we own it. We take responsibility, but that still doesn't help me if I can also still run, to check and find out. But if they run, even in the blog post, it says in the case where they can't recover, they work with the customer and with remediation. So it's even documented in there. If we can't recover the data because it's been too long, it's like, wow, okay, well, I'm still going to run CheckDB because I have the bandwidth just as an extra precaution. So I still encourage my customers to do it. It's just a nasty thing if you have the ability to check for this and not have any data loss, and people aren't doing it. But this is one that it's not out of the box. You have to know to go schedule these. Ola Hallegren's maintenance solution includes the job for running CheckDB. You can schedule it through a database maintenance plan. Multiple ways of taking care of this. Another thing is purging logs. So MSDB, I mentioned through the restore validation that MSDB stores your backup and restore history. If you've written your own backup solution, you're not using Ola Hallegren or a maintenance plan or a third-party utility that will do this for you, then you need to be running sp_delete_ backup history and then passing it the date that you want to delete everything older than that. And this is only clearing the data within MSDB. It's not deleting your actual backup files. I come across MSDBs that are tens of gigabytes, and I go look, and they have every backup restore since the server was built. There's also situations with Service Broker or other systems, DBmail, that might not be cleaning up the log like it should. And there's processes to take care of that. But 9 times out of 10, where I see a bloated MSDB, it's related to backup and restore history. So pretty straightforward. Another is your SQL Server log maintenance. So if you've ever gone into Management Studio and expand the SQL log, and you see that it takes minutes for the thing to populate, or you only have the the active log and 6 rollovers, and you look at the date and it's like, 3 years ago. Yeah. Are you really looking for something that happened 3 years ago through the SQL log? Probably not. Typically, we're looking past few hours, maybe a few days, and you're sitting there waiting to look at everything that's happened since the last service restart when maybe you're only patching, rebooting quarterly or every 6 months. It's kind of wasteful because then I need to go and apply a filter and it has to apply it across that entire log file. Cycling this is simple. You execute sp_cycle_error log, and it starts a new error log. I do this, in a SQL agent job to run every night at midnight, and then I go and change the default value from 6 to another number up to 99. Do you need 99 rollover logs? Probably not, but something that will give you a solid 30 days worth of history is pretty adequate. And the awesome thing is when you go in, you check current day. So you're looking at everything since midnight. If you need to look at the past previous days, you just check the box. So you can roll these things forward. You can actually uncheck the one that you're in, check the next one, and your filter applies and try to narrow down to you find the issue rather than having to scan through everything. Does this help with performance? No, it's just you troubleshooting. It simplifies your life. So I like to do this on all SQL Server builds just to help save time. So deleting your backup history sample syntax. This would delete everything older than January 1, 2018. So just imagine the 2018 says 2021 or 2022. Typically what I do is declare at date, or declare, at date, it's date time, set at date equals get date minus 30, and then execute sp_delete_backup history, at date, and throw that into a SQL agent job. If you're running Ola Halloran, this is a job that's already there. You can look at it and you can change the parameter to be 30 days, 60 days, whatever you want. But pretty straightforward to do. Most customers have this right. I would say maybe 1 in 30, 1 in 50 that I come across, have a bloated MSDB due to backup history. And even those, a lot of times it's they're running OLAs and they didn't know to schedule that job. So they scheduled all the backups to happen, but not the cleanup. All right, let's talk about performance-related things. So statistics. Statistics are what the query optimizer uses to generate your execution plan. Pretty important component here. So if you have out-of-date statistics, SQL Server is using not the best knowledge to generate your execution plan. So think of if you had to make decisions today based on knowledge you had 2 years ago. Are you going to make the best call? It depends, but probably not. It's no different here. SQL Server, the optimizer is only human. It's code written by people. So we need for SQL Server to have as up-to-date information to make decisions to generate the better execution plan. And we do that by making sure our statistics are up to date. A couple of ways of doing this. A process to manually kind of go through and update stats on a regular basis. We do have auto update statistics that are enabled by default. Depending on your version of SQL Server, updates after approximately 20% plus 500 rows of data have changed. With 2016 and up, there is a trace flag we could apply for older versions, but 2016 and up, if the table has over 1 million rows, then it will use a slightly different algorithm. So it's not 20%, it's something less. Still don't know the exact number. It's the equation includes a square root, so it's pretty sophisticated. But it's still, you're relying on it to auto update, and it's still a percentage. So when you're dealing with tables with a large number, I mean, tens of millions of rows or 1 billion rows, even 1% could be 6 months, a year worth of data. So what we'd like to do is, based upon the amount of data change, is update statistics manually in a maintenance job to go through and do that so that you're helping SQL Server along. To hit that tipping point in the middle of the day and then have to update stats, you could take a perf hit. So if you can help SQL and do this ahead of time, during a maintenance window, wee hours of the morning, could definitely help out. So yeah, so Ola Halloran's process, there's a couple of parameters, at update statistics, where there's been row modifications, or you can set the percentage of data change. All right, what about fragmentation? So there's been a little bit of controversy or kind of banter back and forth from some really respected people in the SQL community on if fragmentation is still a concern. I think even Microsoft has weighed in, and it kind of waffles a bit here and there. And it's a lot of it depends, on the situation. So what is fragmentation, or what causes it? It's data modification. So inserts, updates, deletes. Hopefully you have a lot of that going on in your production databases, meaning your company is busy. Way back when, Microsoft did a study on what impact fragmentation has on performance, and they came up with up to 460% based on the size of the environment and the amount of fragmentation. Now this was older versions of SQL, probably pre-SSDs, but anywhere from 13 to 460%. I mean, even the low end, 13% is a lot. I thought this was just contrived data until I had a customer. We migrated their database, and I was brought in basically just to lift and shift, back up, restore, get them set up. So I pre-staged everything, had it done in like 10 minutes. The customer had allocated like 12 hours because it was a multi-terabyte database. And so then they asked, well, since we have the downtime, can I go and compress these two larger tables? And so I did, but in doing so, that's rebuilding an index. I noticed that it was 99.98% fragmented. So I just assumed they weren't doing updating fragmentation because it was just so big and takes so long. Come to find out, no, they had no maintenance going on, no index maintenance, no statistics maintenance. And the whole reason the customer did the migration from one server to another, they were going to a newer version of SQL, more cores, more RAM, faster disk. He was trying to improve an ETL process. So it dropped from 14 hours to 12 with all this horsepower. Customer wasn't happy. When he explained that, I'm like, well, do you mind if I just take a look at the instance? Because I noticed a few things when I was doing the restore and the compression being statistics. So I look at fragmentation, and pretty much every index was 99% fragmented. I looked at statistics, and most were very old. So I asked if I could just go and rebuild all the indexes because he was Enterprise Edition, and it was still a weekend. Yes. So I go through rebuild because a rebuild updates statistics. And the next night, the ETL process ran in under 2 hours. I was woken up because it took less than 2 hours and he thought it was broke. Next night, it runs in under 2 hours. We kept in touch for a couple of months and it consistently ran in under 2 hours. All I did that first couple of days was rebuild indexes. So was it a fragmentation or statistics? It was a combination, but they went from 12 hours to 2. I mean, that's in that several 100% improvement. So what is fragmentation? It's basically white space, empty space in a data in an extent. So as those pages are read into memory, you have wasted space. So Kimberly Tripp has a blog post out there. I think I may have it in a reference slide where you can go and look and see how much of your memory, how much of the buffer pool is filled with wasted space from fragmentation. How do you handle fragmentation? You rebuild or reorganize the index. SQL agent job, OLA's process, database maintenance plan, multiple ways of achieving it. But is this going to be impactful to your system? What about if you have solid state disk? Because that's another thing. Solid state disks are so fast, does it matter? Well, again, it depends. If you have enough RAM that you're not having to go back to disk, even though your disks are fast, they're not as fast as a logical read. It's still a physical. But Jonathan Cahias went through and did an analysis on this, kind of explaining why it matters. So if you have more RAM to fit the whole database in memory, then fragmentation probably doesn't matter as much, but it's that wasted space. So we pay a lot of money for memory, for RAM in the server. So we want to be able to use as much of it as possible. And if fragmentation can get you gigabytes of more RAM because you're eliminating that wasted space, then yeah, it'd be worthwhile to go through and take care of fragmentation. So it's not a one solution for all, but I would say 99 out of 100 of my customers, this applies. What about memory settings? So by default, max server memory is set to 2 petabytes, minimum set to 0. Back in now non-supported versions of SQL Server, so 2008, it managed the buffer pool. 2012 rewrite, it applies to all memory manager allocators. So in a lot of cases, you may need to set max server memory to allow SQL Server to use more memory now. It's kind of a weird thing. It used to be we needed to set it to prevent SQL Server from using too much. Now, based upon internal algorithms, you may find yourself that SQL Server is not consuming enough. The numbers I've been told is when SQL Server would start up, it would allocate 90% of the available memory to SQL. If SQL became under memory pressure, it would look to see how much memory is available and take up to 50% of the available. So think of if I had 1,000 gigabytes and SQL was allocated 900, it's using 900, it wants more. The OS is using 20, so there's 80 available. It would take up to 40. So 940 of the 1,000 would be that the OS now has 60 available that it would never use. So in that case, to tell SQL to use more, then you would have to set the max value yourself. Do I have customers that are still set to the default and they're working just fine? Yes. The biggest thing is to make sure that there's enough available to the OS for it to do what it needs, and that you're not starving the operating system, and that it's not in a perpetual tug of war where the OS doesn't have enough, it has to ask for memory, SQL Server has to release it, the OS gets it, does what it needs to do, and then releases it, SQL Server takes it back, and they get in this perpetual back and forth. So how much memory does SQL Server need? Jonathan has another blog post here. You can go look. He has an algorithm, but the big takeaway is you need to manage or monitor the M bytes available to see how much memory is available and make sure that the OS has enough and that SQL Server is consuming what you expect it to. I don't like seeing servers under 99%, but I like to see that the SQL is healthy, that SQL has enough to do what it needs to do, and that the OS isn't under pressure. So it's a little bit of a balancing act, and it's not a set it and forget it, because if you have reporting services, integration services, other modules installed, then they need resources too. And as time goes on, you may end up building those out more. So there's more integration packages, there's more reports and reporting server. So you may have to back off some of these numbers. But the biggest thing is knowing that this exists and that you can go in and fine tune. What about max degree of parallelism? By default, the setting is 0, meaning SQL Server will use up to 64 cores. There's a trace flag you can set to tell it to use more. In 2008 through 2014, kind of our guidance here was with NUMA nodes with less than 8 logical processors, keep maxed up at or below the number of logical processors. So you could set keep it at 0, and it's up to 8, or you could set it at 2, 4. If you have more than 8, you would start with 8 and then adjust. With SQL Server 2016, it's introduced soft NUMA. So if more than 8 physical cores per NUMA node or socket, soft NUMA nodes are created automatically. So the engine then handles the placement of the logical processors. So we have a little bit more guidance here. With the proliferation of virtual machines, I see a lot fewer 16 and 32 core machines out there. I still work on them. I still have Azure VMs with 32 and more, and customers that have it. But typically, I'm finding a lot of 4 and 8 and up to 16, and then they'll start splitting things off. But if you have a machine with more than 16 logical processors, there's additional guidance here. If keeping maxed up at or below the number of logical processors, those with 16 or more on 2016, then set maxed up to 16. And this is really getting into fine tuning, typically leaving at 0, unless you have certain workloads. You can tune to me, the more important aspect is looking at cost threshold for parallelism. What determines when a query is going to go parallel? So I typically start here. The default value is 5. That's really low. That used to mean 5 seconds. Now it's just an arbitrary unit of math, kind of thing. It's too low. So what should you start with? lot of back and forth with other experts in the community. The consensus, pretty much everybody falls between 25 and 50. 25 is the conservative side, 50 is more of the, all right, I'll set it to 50 and adjust. I've never set a customer between 25 and 50 and had to scale down. It's always bumping up. But if the workload's been there for a while, this article, another article from Jonathan Cahias, is tuning the cost threshold for parallelism. Looking at the buffer or the plan cache to see which queries have been executed parallel, and then looking at their cost threshold for parallelism, and then going through those and determining, would that query process more efficiently if it was maxed up one, basically single threaded. First, can you optimize it? Nope, it's optimized. Okay, is it better running single threaded? Yes. Well, what was its cost threshold? 42. All right, what about the next one? It's 43. Yes, it'd be more efficient at 1. Okay, look and see what that grouping is at. And maybe it's 55. Okay, I'll start my cost threshold at 55. And what that's going to do is cut down a lot on CX packet, because CX packet is just parallelism. Well, we're going parallel on a bunch of trivial queries. Think of kind of the context switching when a kid is hollering at their mom, mommy, 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 just over and over. It's death by 1,000 cuts. Even though mom could still ignore and be focusing on what they're doing, there's all the context still acknowledging the child going back and forth. So I'm taking all these trivial queries, I'm dividing up the work across 8 or 16 threads, running it, and then having to put it back together and return to the customer. It's more work than it's worth if I just did it in a single thread, instead of 16 people doing, working on something and then give me the results and then I sending it off. If I just did it on a single thread. And so that's the parallelism, and that's the cost in eating up and having those CX packet weights, making it where only big work or larger scale sets are going parallel can drastically improve performance. So we control what goes parallel with cost threshold, and then we determine how many threads are being used with the max degree of parallelism. So is it okay that I have 16 and it's maxed up 0 and they're going 16? Maybe, more than likely. But if it's a significant workload and just depending how the workload is, it may be that, well, you know what, it's actually more efficient on 8 instead of 16. But you don't really know that until you see the workload, you observe it, and you start fine tuning. A good buddy of mine was working with a large customer, just happened to be talking with him today, and they tried to reduce down from maxed out 4 to 2 because it was on a four core machine. And nope, it was a 10% penalty going down to 2. So they set it back to 4. It's easy to monitor for this stuff, but the biggest thing is knowing I don't need this default value. I'm going to increase it. And then do I have to fine tune maxed out? Maybe, maybe not. But this for sure. My standard SQL Server builds, I start in that range, usually 35. I kind of split the difference here, but one buddy at a big company, their number is 250. Just saying, it can be big numbers. All right, what about TempDB? So SQL Server 2016 introduced the option as you're installing it. It tries to create a file per logical process or per logical processor up to 8 equal size data files, and this helps with contention for PFS, GAM, SGAM. Now, also versions of SQL Server have helped eliminate contention on PFS, GAM, and 2022 does a major improvement for TempDB to where we might not have to worry about it as much. Do we still need the files? They don't know yet. Time will tell, but it's not going to hurt. So essentially what's happening here is PFS is page 1, GAM is page 2, SGAM is page 3. PFS repeats every 64 megabytes, GAM, SGAM every 4 gigabytes. So if you have a single TempDB data file, and let's say it's 64 meg, you have a single PFS, GAM, SGAM. It can grow up to just before 4 gig, you have a bunch of PFS, but still just 1 GAM, 1 SGAM. So that's where the contention can come in. We solve that by having multiple files, and then TempDB uses the proportional fill methodology. So it will use the largest file, which is why we say 8 equal size data files. So 8 cores or less, equal size data files per the number of cores. So I have a 4 core virtual machine, 4 equal size TempDB data files. Enabling trace flag 1118 prior to SQL Server 2016 says when you create an extent, create all 8 pages at the same time. That helped with GAM contention. That is on by default, as well as trace flag 1117 behavior in 2016 and above, which says when a data file, so one of these TempDB files has to grow in a file group, grow all the files at the same time. So in 2016 and above, that behavior applies to TempDB versus the trace flag applied to the instance, which is why we didn't say turn it on by default. All right, the next thing is, TempDB can come under a lot of contention because the whole instance uses it. So if you can isolate it on its own disk, fast disk, you'll be in better shape. I've had some situations where we've had to split the files across multiple disks to get better throughput and better I/O for TempDB. And then instant file initialization 2016 prompts you to enable that. Check the box. What that means is when TempDB files have to grow and when TempDB is created for the data files, it doesn't have to zero initialize. So it helps with startup time, helps with failover time if you're on a Windows Server failover cluster. It speeds things up because it doesn't have to zero initialize. In manage instance, unless they've changed something, all instances start with 12 data files. Another thing is the default here is, even though 2016 up has multiple files, they start at 64 meg and I think auto grow at 64 meg. That could still be very small for your instance. So let things run for a while, look and see how big TempDB grew. And you can set the initial size to be that. So if my TempDB always grows to 40 gig and I have 4 files, I'll set them to be 10 gig apiece so that the next startup, it's 40 gig. So it doesn't have to grow to that size at 64 meg chunks per file at a time. Again, another death by 1,000 cuts with all those quick growths to get to that size. All right, SQL agent alerts. This is a way of getting some free monitoring. You should have database mail enabled so that you get email notifications when your jobs fail and things like that. So create a mail operator, create the agent alerts. Errors, severity errors 19 through 25 are all fatal errors, meaning the process died and was rolled back. That's bad. A lot of those, the error, I think all but one is you're restoring from backup. So it's pretty significant issues. Errors 823, 824 are related to I/O. And 825 is an I/O operation retry. I just had a customer that this past week that was hitting 825 errors. SQL had a fatal error, created a dump file. Users were still connected, able to do things, but every time we tried to do a log backup or full backup, we got a could not read page error 825, which was an I/O retry, and eventually led to an 824, and then the job would fail. So a restart cleaned that up. But we were notified, or I was notified quite early from the SQL agent alert with the 825. So we were able to take quick action. You can create these using the SQL Server agent or a T-SQL script. I have the step-by-step process listed out and a bit.ly link here to a SQL performance article. Already has all the code. Just change the email operator to you and make this part of your standard SQL Server build. It's free. It's free alerting. It's free monitoring. You should not be spammed. Meaning, if you are, you have some very serious issues. Some of your third-party tools, like the SentryOne SQL Sentry product, checks for these. But if you don't have a third-party tool that's doing these, go create them. Again, free monitoring. Power savings. This continues to crop up. It's getting better. I see less of it, but it still happens. And why it's an issue is, all of your servers and things are shipped with power savings enabled. So it's on in the BIOS. And what it will do for SQL Server is underclock the CPU. So you might go out and purchase a 3 gigahertz, very expensive processor in the server, and then it's going to be underclocked and be running at 900 megahertz. SQL Server is not conducive to that. Certain application loads where they kind of ramp up over time. I can take a 64-core server that's sitting at 2%, run a single query that would cause it to spike to 100 for a few seconds, and get my result set. That's not enough time for that CPU to ramp up from 900 megahertz to 3 gigahertz, so I get the full power. So my workload's going to run crazy. It's going to come in, SQL is going to interpret, generate the plan, and it's, that process could run for minutes. So we need to turn this off for SQL Server. Even Brent Ozar had an article, I forget, it was like Stack Exchange, Stack Overflow, one of those, where they went and bought brand new hardware and then freaked out when they fell over and called him. We're pegged at 100%. What gives? This should be better. And it was power savings on. I've been on several client calls where they would upgrade to better, faster hardware, and their performance just tanked. And on the phone, when they mention, so it's a scoping call, we're trying to, looking to get the business, and they mentioned we just changed hardware. So what's your power savings? Oh, it's balanced power. Oh, well, that should be high performance. And we hear click, and then you could hear the gasp where it just plummets to 20%. And so, hey, we're back to normal. All right, awesome. Call us back when you have another problem. So nothing billable. We just, it was that, and it still happens. I see it less and less because VMware and EMC and Dell and all these companies have in their published documentation, if this is for a SQL Server workload, turn it off in the BIOS. And so admins are agreeing with that, and so they'll turn it off, or they'll have dedicated clusters, VM clusters for SQL Server workloads. But I still come across it. CPU-Z is a free tool. I usually demo it in my workshops and things. So cpuid.com, you can download it. It's just the executable runs on the server, and you can see what the current clock speed is and what the chipset is. So I can see it's a 3 gigahertz, but I'm running at 1.2, 900 megahertz to be able to see that in action. There's also things where you can go through and benchmark and stress the CPUs and things. Glenn Berry, a good buddy of mine, he loves the tool, has YouTube videos out there step-by-step how to run it and looking at the various settings. So it's a good tool to help look at if you're underclocked. All right, so one of my favorite sayings, SQL Server is great, but a next finish install is not always good. I mean, it's good for us consultants out there because it keeps us in work, but with your organization, just make sure you have proper backups, that you're running those consistency checks. Any type of log cleanup, if you're noticing that MSDB is getting more than a few hundred megabytes in size, you probably have something that's not purging like it should. So take a look at that. Making sure that your statistics are up to date so that SQL Server has the best opportunity to, or the query optimizer has the most up-to-date information to generate the execution plan. Index maintenance, I mean, wasted space in memory. I mean, I want as much of the data in the buffer pool than just wasted space. So take care of fragmentation. Your memory settings, those can still be a factor. Most everybody will still go in and set a value versus just letting it dynamically set. Max degree of parallelism and cost threshold. Take a look at cost threshold first, and then tune max stop as needed, and then making sure that TempDB is proper for your instance. I still see it even with 2016 and up builds, with Azure VM builds, where it's still set to a very low auto growth or there's not enough files. So take a look at that and configure it properly. Configure the free SQL agent alerts, and then lastly, make sure any power savings is disabled. Now, is that you that can change the power savings? I mean, you can go and look at the power settings and maybe set the balance or the high performance, but chances are that's set from a group policy object. You'll need to work with somebody to have it turned off at a GPO, and then more importantly, have it off at the BIOS. For that, any questions? And my contact info, I'm on Twitter at tradney, and then tim@timradney.com is how to reach me via email. But y'all can come off mute and ask questions if you'd like.
Yeah, feel free to come off of mute, everybody. I'm sure there's some questions.
Even if it doesn't pertain to this, we have looks like a good group of people still on. It's the consulting hour. I mean, ask questions. Somebody surely has some input.
I'll stop the recording. Then people will ask questions.
That's right. They don't want to be tied to this